Hooray! Here we go. One wave. The most basic way to describe a wave is using a sinusoidal function, a simple sine function. What does a sine function describe? Something that goes up and down and up and down and swings back and forth. When we're talking about surface gravity waves here in this tutorial, there are many other type of waves, but we are focusing on these surface gravity waves. So whatever I say wave here, you can actually associate a change of the sea level. Sea level going up and down. So now what are the basic wave properties? How can you describe a wave? You essentially only need three properties. You need to know what is the wave amplitude. So if you have an undisturbed surface, then the wave amplitude tells you how much the sea level goes up, the maximum. For tides, we call it the high tide or high water. This is plus a 0. This is what we call here wave amplitude. Then it swings back to the undisturbed, and then it goes back. Then it goes down by an amount of minus the amplitude and swings back. What we call the entire range, okay, from maximum to minimum is, we call it wave height, okay, or the tidal range. For the tides, we call it tidal range. So 2 meters tidal range is from maximum to the minimum, a 2-meter change, okay, but the average sea level is between. Okay, so then the other two properties is, one is the wavelength. Okay, you take a picture of the wave and tell me what's the distance between two wave crests. Okay, all right, that's easy, isn't it? It's just a snapshot. Wave period is something else. Wave period is the time it takes from one wave crest to the next wave crest. So you measure the time. Okay, so wave period and wavelength are totally different things. Okay, but they are related to each other. Okay, they are related to it. They are not totally independent. So you can't have any combination. Okay, so this is what we start, and that's essentially like a tide, or the components of the tides can be described by these sine functions. Okay, I should also mention here, so what's, just for completeness, so what's in here is, in this argument of the sine function, let's get the laser pointer activated, yay! In this argument of the sine function, you can see that there's the wavelength in there, there's the period in there, and the variables are spatial coordinates and time. And we just assume a very simple wave that only propagates in the x direction, into one direction, say to the east. Okay, 2 pi just refers to a complete cycle. Okay, you know that this is in radians, the sine function, and we also have a phase lag here. Phase lag is useful if you have more than one wave. This one refers to the initial state of the wave. At time 0, what amplitude, what signal do you have at time 0? Okay, and then if you compare more than one wave, they might have a phase shift between the waves. Yay! Okay, so now comes the next important detail.